Hi everyone and welcome to my channel. I'm Alex and I'm gonna show you in this video how you can reduce Firestore costs. This is a video for an article that I wrote, link is in the description below, which was recently published on the Firebase tips and tricks publication on Medium. Let's begin. As you already know, Cloud Firestore is a scalable, cloud-hosted, NoSQL real-time database from Firebase and Google Cloud, and it's optimized to store large collection of small documents. When using Firestore, the mechanism for billing is related to the number of reads, writes, and deletes we perform. Since the most frequent operation in an application is the reading, we should always design an efficient database structure in order to avoid higher bills. So I'll try to explain in this article a solution that can be applied to multiple types of Firebase projects. I will take a concrete example just to make it easier to understand. So stay with me till the end. I think that nowadays all of you are familiar with YouTube, Facebook or Reddit. In each one of these projects, the users can interact with each other through comments and replies to comments. So a popular post or a video might get thousands of comments, or why not even tens or hundreds of thousands of comments and replies. I've personally seen a single YouTube video getting millions of comments. But how can we create an efficient Firestore schema for such an app? Since we know that Firestore can massively scale using large collection of small documents, the initial response for most developers is to create a schema that looks like this. Which is actually not bad considering the fact that each video has a sub-collection of comments and each comment has a sub-collection of replies. So unlike in Firebase real-time database where to display a list of videos, we should have downloaded the entire videos not together with all children beneath it. In Cloud Firestore the things are different. So if we download a document, we are just getting the data in the document and nothing more. No documents from any sub-collection. This is happening because the queries in Firestore are shallow, which means that it only gets documents from the collection that the query is run against. So we don't have to worry about any sub-collection or sub-sub-collection. Because most of the time we create a separate page for each type of data we want to display, such a schema makes sense. This is because we can create a query to get all videos and nothing more. If we want to see a single video, then we need to dig a little deeper in the database to get the corresponding comments and replies. So the above structure can be also remodeled like this. Doesn't this look a little familiar? It's almost the same structure as before, but instead of having nested sub-collection, we have used top-level collection. Are there any benefits in using this solution? I have answered a few days ago a question on Stack Overflow regarding this topic. As a matter of fact, this solution looks a little more organized. The problem is that there are still 3 database calls that we need to perform in order to get the desired data. However, both solutions might work at a reasonable price only for a small amount of data. How about having hundreds or even thousands of comments? In this case, we should nest all the comments within an array in each video document and all the replies in an array within the comment object. This solution will require a single document read. It sounds awesome, right? But in this case, there are some limits when it comes to how much data we can put into a single document. According to the official documentation regarding usage and limits, the maximum size for a document is 1 megabyte. So a single document can grow up to a total of 1 megabyte. Honestly speaking, when it comes to storing text, we can store pretty much, but as the arrays become larger, we have to be careful about this limitation, because if you reach the maximum limit, the writes may start to fail. Luckily, in Android, there is a library called Firestore Document Android, which can help us always check against the maximum quota. Are there any benefits of using this solution? Yes, there are. Cloud Firestore Listener fire on the document level, meaning that when we read a video document, we download all the details of the video along with the comments and replies. So in this case, there are no additional database calls that we need to perform in order to display the comments and the corresponding replies. Are there any improvements we can make? Yes, there will be one. If the fields of the video document other than the comments array might hold a significant amount of data, then we can get both arrays out of the video document and create 2 separate top-level collections named comments and replies. To get the comments of a specific video, we have to download the document with the video ID that exists in the comments collection, and to get the replies of a specific comment, we have to download the document with the comment ID that exists in the replies collection this time. Now, let's imagine we have a number of comments that don't fit into a single document, and the number of replies that don't fit in the single document either. Remember the Gangnam Naman style video? By the time I'm writing this article, has over 5.2 million comments. Getting the comments and the replies out of the video document isn't still a bulletproof solution, because both documents can hit the maximum size. Then, how can we structure a Firestore database to hold such a large number of comments? Are there any solution for improvement? Yes, there is one. We can refactor the database by sharding the comments and replies over multiple documents. The single problem that we can have here is to find a predictable name for each document. It can be the date or even a date and a time frame. So let's take the comment collection as an example. This means that we'll have a different document for each day in a year. That's about 365 megabytes. And we can go even deeper, as you can see in the second example. This means that for a single year, we can have up to 8,760 megabytes of data. That's a lot of space for comments and replies. Now, this schema raises a new question. How to query Firestore to getting all the comments? Well, the answer is really simple. In short, we should use a query that looks like this. I wrote also a detailed article regarding this topic, which is called How to Query Collection in Firestore under a certain path. But how about the replies? In the same way we did with the comments, we can also do with the replies. So, in conclusion, I have seen so many attempts to find solution for minimizing Firestore cost, but this looks like to me the simplest one. We certainly can reduce the number of reads consistently. We can narrow the number of reads from millions to only tens or hundreds. So these are the solutions that can help us reduce Firestore cost. According to the size of the app, you can choose one or the other solution to optimize the cost. So I hope you found this article useful, and if you have any question regarding this topic, feel free and leave a comment in the section below. So in the end, guys, you can check the entire article on Medium, and if you enjoyed the video, please hit the like button. But if you think you learned something new, please subscribe to my channel as more videos are coming. Bye!